gas metal arc welding. The reason why we call it gas metal arc welding is that the electrode is metal, and then we use a gas to shroud the area from welding, from the oxygen in the environment. Okay, so in the previous process, shielded metal arc welding, we used coating on the electrode to get all the to scavenge all the oxygen out of the air, and to keep that area around the weld free of oxygen contamination. Also, nitrogen is a problem. So what we're doing here is we're actually taking, we have a nozzle, some gas, inert gas is going to come out of the nozzle from the tank, out of the actual gun, coming out of the nozzle and shielding the area we're going to weld. This particular gas is a mixture of argon and carbon dioxide. Okay, the gun has a trigger. When you pull the trigger, the wire will start to feed and the gas will start to come out as well. Okay, so we got to make sure we have this machine set up properly though. This is a very expensive machine. Make sure everything's set up. Have an instructor look at it before you go to weld. Okay, the way this machine works is the wire is fed off of the spool through the wire whip to the gun, and the way that works is we have two drive rolls. Okay, so as these drive rolls turn, they push the wire all the way down to the gun. Now we got to make sure that we don't kink the actual hose here. Okay, the reason for that is if we kink it, the wire can't flow through it smoothly. If at any time the wire gets nested up here, it stops coming out of the gun. Don't keep pushing the trigger because you're probably just making a mess inside of this box here. It's trying to push the wire can't go, so it's actually just piling up wire on the inside of the box. Okay, let's talk about the control. Okay. Gas metal arc welding is a constant voltage process, which means that we're going to set the voltage and the current is going to go up and down in order to compensate and keep the voltage at the same spot. Okay, remember current and voltage are related to each other. Okay, we want to use a constant voltage, so CV is what we want to set this to at this point. Okay, constant current would be up here if we're doing shielded metal arc welding. We're not going to do this machine is not set up for shielded metal arc welding. Okay. In your handout, it says to start around 26 or 25 amps, or sorry, volts. And this particular material, that was for the thicker material. This particular material probably want to start down at about 24 volts, so that we don't burn through it right away. Okay, we can turn it up a little bit. You're going to have to optimize your settings for your particular part. Okay, practice on a scrap piece. You can pull a scrap piece out of the scrap bin and practice on that first. Try to make the piece that you're practicing on though the same thickness as your padding plate. Remember that you want to have a good amount of material on the back side in order to make your plate a little thicker, so that you have more. You can use a higher voltage in order to weld on it without burning through. Okay, any other settings on this? The arc control you can put at 50%. That's not very important. And the contactor, in this case, we want it to be on remote. What they mean by the contactor is how do you turn the gun on? The trigger turns the gun on, so we want to have this on remote. Otherwise, if this is on all the time, that means that when you touch the tip of your electrode, that wire to the workpiece, it's going to melt up into the tip. It's going to melt into the gun. Okay, so we want to make sure that's on remote, and that the actual voltage adjustment is on the panel, the switch here, and we're going to adjust it right here. Okay, so around 24 or so volts. Okay, come up to here. This is the wire feed control here, and you're going to change the actual speed, and the speed is in inches per minute, IPM. Okay, so you can go anywhere from 100 to about 500 inches per minute. Okay, we're going to have it around 250 or so to test this. Okay. Also, we need to turn this unit on as well as the base unit. One other thing that you have to have is the shielding gas has to be on. Okay? So what you're going to do is, this should be all the way off over here. Okay? Clockwise turns it off. When you find this machine, it should actually have 0 reading on there for both tanks. Turn this on. Actually, I'm not sure if this one actually does change. You can see that both dials are at 0. This should be the way it is when you leave the lab. Okay. Okay. So what you're going to do is you're going to slowly open the valve up. Okay. Open it all the way up, and then go back about a 1/4 turn. Takes a while to do. Okay. Up all the way back about a 1/4 turn, and we want about, this is cubic feet per hour. This is the amount of gas coming out. Okay. About 30 cubic feet per hour. You can see there's a little mark there. Is about what we want. Okay. Come on down here. Look at this. This little button right here is called purge. This will allow gas to escape. Okay. And both the machine and the power for this, the wire feeder has to be on in order to do that. Okay. Now when I pull the trigger, you can see the gas and the wire starts to extend. Okay? We don't want to start welding with that much wire sticking out of there. What we want to do is cut this off close to the tip. Okay? There should be a set of cutters on the actual welder. Okay. So the padding plate you'll have welded on the back side, all the way across the back side. Maybe a couple layers so that we have the right thickness, otherwise we'll burn through. What we're going to do is, we're actually going to take, and with this welding process, we're going to push the material along. You're actually going to push it this way. You can weld in both directions. You can actually drag or push, but when you're learning, it's easier to push it because you can see what's actually happening as you're welding. Okay? What you're going to want to do is you're going to want to move back and forth a little bit as you go along. And this side-to-side pattern will spread the metal out a little bit and make the bead a little bit more flat. You don't want a bead that's real high and round. You want it to be nice and semicircular, probably no more than a 1/16 of an inch off the plate and about 3/8 of an inch wide. So that's what you're going for. We'll actually weld one. We'll see how it comes out. I don't think the camera does a very good job at watching the weld, so I actually have to do a demonstration in the lab later on. Yeah, a little better. Alright. Okay, notice that with this process, you don't see any slag on it, so you don't have to go chipping with a slag hammer and denting it all up. So that's pretty good. I think I need to turn the voltage up just a little bit though. It's a little bit too high. Okay, so I'm going to turn up the voltage. So what I'm going to want you to do is do 3 or 4 beads similar to that on your plate, and don't overlap them this time. So I'm going to put another one. I'm going to leave about 1/4 of an inch next to it and put another bead on there. So we found a pretty good setting, was about 23 volts and about 375 inches per minute. You do have to move along pretty good and move side to side, but you'll get less spatter if you have those settings than if you have a higher voltage. If you turn the voltage up to 25, 26 volts, you can get good penetration, but you're going to have a lot of spatter on the surface, little adhering droplets of metal. Okay, I want to go through the shutdown procedure on this. What we're going to do is first turn off the gas all the way. Remember, righty-tighty, lefty-loosey. Turn to the right, clockwise, turns it off. Okay? We still have pressure on the regulator though, so we need to purge the regulator. Push this button until 2 valves have I've totally went to 0. And then we're going to turn both units off. Okay, up here and down there. Okay, make sure you clean up your area. You should have a hammer, a chipping hammer, pliers, okay, electrode holder. You need to clean underneath. You need to clean underneath where the grate is. All around here, all the slag, it'll be a mess. You need to clean up. I don't want to see one piece of slag. You have to clean under the cables. It's kind of a pain, but don't leave until the person on cleanup says you can. Okay? Or I do. So have fun welding.